previous class, I was told you what is the determinant and minor and cofactor and how to solve the second order determinant and third order determinant. Now we are discussing about cofactor and minor, and also how to find the cofactor of these matrices and formats. So how to find the cofactor of C11, C13, C22, C12, C21, and C6. So let us start how to find the C11. Cofactor of the formula is Cij equal to plus Mij in I plus j equal to J. Again, minor Mij in I plus j equal to or else. That is the formula cofactors. So now using this formula, how to find the cofactor of the determinant? A equal to 1, 2, 3, 2, 3, 8, 6, 4, 5. And the same here. So now, so the here you got cofactor of C11. So let's C11, C11. That is 1 plus 1 is equal to 2. That is even. So now using the formula that is L11. M11 is the minor of M11. Like deleting height row and j follow. That is 3, I, 4, 1. Now the principal diagonal, then secondary diagonal. That is 3 minus 1 is equal to minus 7. That is the cofactor of C11. Similarly, how to get the cofactor of C12? C12. C12 means the adding the ith row and j column. That means I equal to 1 and also j equal to 2. Then that is I plus j equal to 1 plus 2 equal to 3. That is odd. Then the value of ith row and j column, the adding the value of C12, when you get this odd, then using this 3. Then that is minor M12. Minor M12. Similarly, M11, M12. So that is you get the cofactor of 2. So now deleting ith row and also I column and j row. That is 2, I, 6, 1. Now the principal diagonal, then secondary diagonal, minus 2 minus 10. And we get the value is 28. So similarly, we get value of C13, C22, C21, and C32. That is the about the cofactor of the determinants. Now, what is the value of the determinant A, B, C, 0, A, B, and B, O, A? I know anything. The given determinant is J equal to A, B, 0, and also 0, A, B, then B, 0, A. That is third order determinant. So third order determinant can be solved in 6 ways. Either row 1 or row 2 or row 3, or similarly column 1 or column 2 or column. We can use any one of the ways to find the value of determinants. Now we have to expanding along R1. Expanding along R1. So let equal to A into K square minus 0 minus B into 0 minus B square. Similarly, plus 0 into 0 minus B. That is expanding along R1. So that is K new minus plus negative. This term is equal to 0. That is, we get A cube plus negative. Then answer is A cube plus B cube. Now, the next question is the ideal value of K. If this determinant is equal to 4. So let's 1, 4, 0, and 2, 3, 1, also 3, K, 4. Determinant is equal to 4. So now to get the value of K. So this determinant is expanded either in one row or in one columns. So now we have to expanding along R1. Expanding along R1. Now we see 1 into 6 minus K minus 2 into 4 minus 3 plus 0 into something is equal to 0. That is not required to find the value of formula has always 0 into something. So now we get 6 minus K minus 2 into Y equal to 6. That is 6 minus K minus 2 equal to 4. 4 minus K equal to 2. That means minus K equal to 2 minus 4. Minus K equal to minus 2. That is K equal to 2. That is the referred solution of third order determinant given by the value of K. Also, prove that 1z minus y and minus z 1x and y minus x plus 1, that is 1 plus x square plus y square plus z square. How to solve? So that these determinants can be expanded any one row or any one column directly. Then we get 1 plus x square plus y square plus z square. And next is the determinant that are 0. The determinant of a matrix will be 0 if an entry row is 0 or 2 rows or 2 columns are equal or a row or column is a constant multiple of another row or columns. Given that the determinant that are 0, the determinant of a matrix will be 0 if an entry row is 0. So here, del is equal to 0, 0, 0, 1, 2, 3, 4, 5, 6. It will be the other determinant. So given that n1 row or n1 column is 0, n1 row or n1 column is 0, so then determinant is equal to 0. Why it is 0? So 0 into expanding, then minus 0 into expanding, plus 0 into something, so that is equal to 0. So it is given that the determinants of a matrix will be 0 if an entry row is 0, but 2 row or 2 column are equal, or a row or column is a constant multiple of another row or column. Next, the properties of the determinant. The value of the determinant remains same. Each row and columns are interchanged. The value of the determinant is remains same. If we interchange rows into columns or columns into rows. Let us example. Let del equal to A1, B1, C1, A2, B2, C2, and also A3, B3, C3. Understand? Suppose the expanding that determinant, let it be alpha. Say, then delta. Delta means interchange. The value of the determinant remains same if the row and columns are interchanged. Now, the interchanging row to columns. That is R1, R2, and R3. That is column 1, column 2, and column 3. If we interchange both rows into columns or columns into rows, but value of the determinant remains same. That means K1, B1, C1, and also A2, B2, C2, and A3, B3, C3. So now we see that the expanding that determinant in row 1 or row 2 or row 3, let it be value of the determinant is alpha. So similarly, if we interchange rows into columns or columns into rows, we get the value of the determinant also alpha. So that means del is equal to del del. That means transpose of any E cross 3 square matrix to form of a determinant, then the value of the determinant is always same. The value is always remain same. For example, let del equal to 1, 4, 1, 1, 0, 2, 3, 2, 1. So now expanding that determinant equal to 1 into 0 minus 4 minus 2 into 1 minus 6 plus 1 into 2 minus 0. So that is minus 4 plus 10 plus 2. That is minus 4 plus 12. We get value of the determinant is 8. Value of the determinant is 8. Expanding along R1, then the value of the determinant we get is del. So property says that the value of the determinant remains also if the rows and columns are interchanged. The value of the determinant remains same if the rows and columns are interchanged. Suppose we have to interchange all rows and columns. That is del dash. Del dash equal to 1, 2, 1, 1, 0, 2, and 3, 2, 1. Now interchanging all rows and columns. All columns and rows. So now by expanding that determinant, we get 1 into 0 minus 4 minus 2 into 1 minus 6 plus 1 into 2 minus 0. So that is minus 4 plus 10 plus 2. That is minus 4 plus 12 equal to 8. So now the value of this property is say that the value of the determinant remains same if we interchange rows into columns or columns into rows. So expanding R1 and also interchanging that is column, that is C1, column 1. That is R2, that is C2. And that is R3, that is C3. Well, now expanding to our row, we get A, then interchanging its position, rows into columns, then value of the determinant also same. So that is del equal to del dash. That is the hard properties of the determinant. Then the next property is say that if any two rows of a determinant be interchanged, then the value of the determinant is changed in the sign line. Therefore, if any two rows of a determinant, if any two adjacent row or columns of a determinant are interchanged, then the sign of the determinant is changed, but value remains same. Any two row or any two columns are interchanged. So next property is if any two row or column, any two adjacent row or column of a determinant are interchanged, then sign of the determinant is changed, but value remains same. कौन डिटरमिनेटर आम जब पाखापाखी रो कि पाखापाखी कलम टाक जब आम इंटरचेंज करुचे ताले डिटरमिनेटर साइनटा हूँ कौन कह चेंज हो किंतु वैल्यू रिमेन सेम आम नवा सो धर डेल नवा के डेल इज इक्वल टू धर 1 2 1 1 0 4 2 1 ये डिटरमिनेटर को आम नवा select del is equal to 1 to 1 and 1 0 2 and 3 to 1. So, sir, what time later did I expand for the chain? Now 1 into principal diagonal minus secondary diagonal minus 2 into 1 minus 6 plus 1 into then 2 minus 0. So that is minus 4 plus 10 plus so that is sense. বুঝে লাগি তাহলে আমি যদি রো ওয়ানটাকে আমি এক্সপান্ড করুছে রো ওয়ানটাকে এক্সপান্ড করছে তাহলে আমি পাউছে দ্য ভ্যালু অফ দ্য ডিটারমিনেন্ট ইজ 8. ওকে তাহলে সেটা হচ্ছে এনি টু adjacent রো অর কলম অফ adjacent মিন্স এ রো চেঞ্জ হইপারিব মানে দ্যাট মিন্স R1টা মে বি ইন্টারচেঞ্জ ইন্টু R2 or also the R2টা ইন্টারচেঞ্জ ইন্টু R3. No changes in R1 and R3. R1 R2 ଆମେ ଚେଞ୍ଜ କରିପାରିବା or R2 R3 ଚେଞ୍ଜ କରି R1 R2ଟା ଚେଞ୍ଜ ହେଇପାରିବ. ସେ କହୁଛି any two adjacent row or column of a determinant are interchange. Then sign of the determinant is changed, but absolute value remains same. এইটা হচ্ছে absolute value. Absolute value সাইনটা কোন হচ্ছে প্লাস. তাহলে আমি any row or any column কে আমি যদি interchange করতে but suppose we have to change R2 to R1 and R1 to R2. Well, the cost del is equal to we see then change 1 0 2 and also 1 2 1 then 3 2 1. So now we get 1 into 2 minus 2 then minus 0 যা লিখলে 0 that is not required plus কেতালা 2 into 2 minus 6 তাহলে that is 0 minus 0 plus 2 into 2 minus 6 equal to minus 4 that is minus 6. Therefore you see that the del or del S. So then that original determinant যদি আমি expand করুছে we have to expand in original determinant তাহলে then value of the determinant is a. তাহলে any two adjacent row or column to interchange কলে তাহলে that means we have to change R2 to R1 and also R1 to R2. তাহলে then we get the value is 8. So any two row or any two column যেতবে চেঞ্জ করুছে বা any two row or any two adjacent column or row চেঞ্জ করুছে তার মানে সাইন only change. That means plus then we get হচ্ছে minus what absolute value remains same. Absolute value remains same. Now we have to change, suppose we have to change C1 to C2 and C2 to C1, then also we get same value. Where C1 is changed to C2 and C2 is changed in C1, then expanding, then that is get hচ্ছে minus 8. তাহলে any two adjacent row or column of a determinant are interchanged, then sign of the determinant is changed, but absolute value remains same. Third properties. What is the meaning of the third properties? The third property is say that if two rows or column of a determinant are identical, so then value of the determinant is 0. Identical means same. Identical means the value is the same. মানে same দেখি আপনি মানে result is কোন হবে same. তাহলে then value of the determinant is 0. তাহলে suppose then equal to A1 B1 C1 A1 B1 C1 and A2 B2 C2. Well, in given third order determinant, we see that the R1 and R2 are identical. R1 and R2 are identical. Identical means R1 is the same element and R2 is the same element. That is called identical. That is the value of the determinant is 0. How to solve, how to know that is going to when two row or two column, but all row or all columns are same, the value of the determinant is 0. Let it be one example. Let it be del equal to 1 so 1 and also 1 so 1 1 0 1 1 0. Let del is equal to 1 1 2 1 1 so 3 into 0. Now expanding that determinant, we get 1 into 0 minus 4 minus 1 into 0 minus 6 plus 2 into 2 minus 3. That is minus 4 plus 3 minus 4. So now the cancel out to minus 6 and plus 6, we get 0. And from this example, we clear that any two row, at least any two row or any two columns are identical, then value of the determinant is 0. So not only at least 2 rows or 2 columns. Let it be one example. Let then equal to 1 2 1 1 2 1 1 2 1. That is 3 rows are identical. That is R1 equal to R2 equal to R3. So write down only G. Suppose column let del equal to 1 2 3 1 2 3 1 2 3. So that is also 0. Why it is 0? Because C1 equal to C2 equal to C3. All columns are identical. All columns are equal. So the determinant is 0. So third property is say that at least any two row or any two columns of a determinant is identical. So then value of the determinant is equal to 0. So the next is if every element if every element of a row or column of a determinant is 0, so then value of the determinant is 0. If every element of a row or column of a determinant is 0, so that means let del equal to 0 0 0 A1 B1 C1 A2 B2 C2. So that is the value of the determinant is 0. The fourth property is say that any one row, all the elements are 0, and then determinant is equal to 0. At least, or del equal to 0, 0, 0, 0, 0, 0, 1, 4, 3. That is also a 0. Why it is 0? Because one column is all elements 0 and second column is also 0. And that means any one row or any one column contains 0 elements, so then value of the determinant is 0. Then next property. If all the elements of any row or column multiplied by the same number, so then the determinant is multiplied by that numbers. So let del is equal to D is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3. That is the original determinant. The value of the determinant, let it be A. Say, if all the elements of any row or column multiplied by the same number, then the determinant is multiplied by that number. The another determinant is del dash. Let it be K C1, K B1, K C1, A2 B2 C2, A3 B3 C3. So then the value of the determinant is K check Kx. Now original determinant is value is x, then del dash column multiplied by the same number. Multiplied by the same number means k. That means when the taking out the k we get A1 B1 C1 A2 B2 C2 A3 B3 6. The determinant is said that any one constant factor by any one constant term in same number can be taken outside of the determinant. So taking the common logic K, Then determinant again converted A1, B1, C1 and A2, B2, C2, A3, B3, C3. Now first we checking the determinant is for value is x. So put this value in the given determinant k into x. So that means if the elements of any one row we are all multiplied by the same number, then the determinant is multiplied by that number. So you see the example, so D is equal to, given that D is equal to P, Q, R, A, P, Q, R, A, Y, Z, L, A, N. That is the given determinant, one of the determinants. So says Motoruchi, well, if find that, find the value of the determinants, this is equal to what is the value of the determinants? So let del is equal to P, Q, R, I, 23X, 23 Y, 23 Z, L, M, N. What is the value of the determinant? Already I told you that checking any same number of percent in any one row or any one column. So taking 23 in R, taking power someone 23 power R. So now get del equal to 23 into P, Q, R, X, Y, Z, L, M, N. 23 into the then determinant is equal to this. That is 23 this. That is the value of the determinant. That is the value of the determinant. Similarly, next example is taking 23 in column 1, then value is 23 B. अच्छा नेक्स्ट एग्जाम्पल is 3, 7, 8, minus 9, 2, 11, 18, 42, 48. So one of the example is del equal to 3, 7, 8, minus 9, 2, 11, and 18, 42, 48. That means 3, 7, 8, minus 9, 2, 11, 18 is converted as 3 into 9.
Or can we call it the time? It helps. This is I think Austin. Yes, I think so.
अच्छा 3 del equal to 3, 7, 8, minus 9, 4, 11, 18, 42, 48.
That way good. And this
अच्छा 3, 7, 8, minus 9, 2 into 11, 18 is converted as 3 into 6. And 42 is converted as 7 into 6. And 48 is converted as 8 into 6. So that means 8 is converted as 3 into 6. 42 is converted as 7 into 6. 48 is converted as 8 into 6. Now, the same number arises from row 3. 6 and 6. So taking common 6 from R3. Well, then we get 3, 7, 8, minus 9, 2, 11, 3, 7, 6.
Yes.
So that is 6 into 0. Why it is 0? Because the R1 equal to R3. R1 equal to R3. So that is 0. So next property is say that any one constant term can be taken the outside of the determinant. But same number can be taken outside of the determinant. Whenever the value of the determinant is 0 by any numbers, when you get, then you check that any one row or any one columns are identical or not. When any row or any column are identical, then you put value is 0. So otherwise, simplify and then expand. Okay.